easy explanation. What is sound and how is it made? Sound is a type of energy that we can hear with our ears. Every sound you hear, whether it is a person talking, a car moving, or a drum being played, is made in the same basic way. Sound is produced when something vibrates. Vibrations mean a very fast back and forth movement. For example, when you hit a tabla, the skin of the tabla starts moving quickly. This movement is called vibration. These vibrations create sound. When the vibrations stop, the sound also stops. You can feel this yourself. Put your hand on your throat and speak. You will feel your throat shaking. This is because your vocal cords are vibrating to produce sound. So, one very important point for exams is, sound is always produced by vibrations. How a tabla produces sound. When you hit a tabla, its surface moves up and down very fast. This movement creates vibrations in the air around it. These vibrations travel through the air and reach your ears. If you want to make a louder sound on the tabla, you need to hit it harder. When you hit harder, the vibrations become bigger and stronger. Bigger vibrations produce louder sound. So remember, strong vibration gives loud sound. Weak vibration gives soft sound. How sound travels. Sound does not stay in one place. It travels from one place to another. Sound travels in the form of waves. These waves move through a material like air, water, or solid objects. When an object vibrates, it pushes the air particles around it. In some places, the particles come closer together. These are called compressions. In other places, the particles spread apart. These are called rarefactions. These compressions and rarefactions move forward through the air. This is how sound reaches your ear. An important thing to understand is that the air particles do not travel all the way from the source to your ear. They only move back and forth and pass the energy along. Why sound cannot travel in vacuum? Sound needs particles to move. In air, water, and solids, particles are present. So sound can travel in them. But in vacuum, there are no particles at all. Because of this, sound cannot travel in vacuum. That is why in space, there is no sound. This is a very common MCQ point. Speed of sound. Sound travels at different speeds in different materials. It travels fastest in solids because particles are very close together. It travels slower in liquids and slowest in gases because particles are far apart. For example, sound travels faster in steam than in water, and faster in water than in air. How we hear sound. Our ears are very special organs that help us hear. The ear has three main parts: outer ear, middle ear, and inner ear. First, the outer ear collects sound waves. The part you see on the outside is called the pinna. It collects sound and sends it into the ear canal. Then the sound reaches the eardrum. The eardrum is a thin membrane. When sound hits it, it starts vibrating. These vibrations pass to three very small bones inside the ear. These bones are called hammer, anvil, and stirrup. They make the vibrations stronger. Then the vibrations move into the cochlea, which is filled with fluid. Inside it, there are tiny hair-like structures. These tiny hairs change the vibrations into electrical signals. These signals travel through a nerve to the brain. Finally, the brain understands these signals as sound. If any part of the ear is damaged, especially the eardrum, a person may not hear properly. Pitch and frequency. Pitch tells us whether a sound is high or low. For example, a child's voice is high pitch and a man's voice is low pitch. Pitch depends on something called frequency. Frequency means how many vibrations happen in 1 second. If vibrations are very fast, the frequency is high and the pitch is also high. If vibrations are slow, the frequency is low and the pitch is low. So remember, fast vibrations produce high pitch. Slow vibrations produce low pitch. The unit of frequency is hertz. Hearing range. Humans can hear sounds between 20 and 20,000 hertz. Sounds below this range are called infrasound. Humans cannot hear them. Sounds above this range are called ultrasound. Humans also cannot hear them. Some animals can hear these sounds. Dogs can hear higher sounds than humans. Bats can hear very high sounds. Elephants can hear very low sounds. Musical instruments and pitch. The pitch of sound in musical instruments depends on several things. Short and thin strings produce high-pitched sounds. Long and thick strings produce low-pitched sounds. If you tighten a string, it produces a higher pitch. If you loosen it, the pitch becomes lower. That is why musicians adjust the strings of instruments. Loudness and amplitude. Loudness tells us how loud or soft a sound is. Loudness depends on amplitude. Amplitude means how big the vibration is. If vibrations are big, the sound is loud. If vibrations are small, the sound is soft. For example, if you hit a drum hard, it produces a loud sound. If you hit it softly, it produces a soft sound. Loudness is measured in decibels. Noise and hearing damage. Noise is unwanted or unpleasant sound. Very loud sounds can damage our ears. Listening to loud music for a long time can cause hearing loss. As people grow older, their hearing becomes weaker, especially for high-pitched sounds. Sound waves and their properties. Sound waves have three main features. Wavelength is the distance between two similar points in a wave. Frequency is the number of waves passing in 1 second. Amplitude is the height of the wave and shows how strong the sound is. High-pitched sounds have high frequency and short wavelength. Low-pitched sounds have low frequency and long wavelength. Loud sounds have high amplitude. Soft sounds have low amplitude. Pleasant sound and noise. Pleasant sounds, like music, have regular wave patterns. Noise has irregular wave patterns and does not sound pleasant. Loudspeaker working. A loudspeaker produces sound when its cone vibrates. If the cone vibrates strongly, the sound is loud. If it vibrates very fast, the sound has high pitch. If it vibrates slowly, the sound has low pitch. Simple experiments. Sound can travel through water. If you put a ringing object in water, you can still hear it. Sound can also travel through solids. If you tap one side of a table and put your ear on the other side, you can hear it clearly. Important answers for exams. Sound cannot travel in vacuum because there are no particles. Sound travels faster in solids because particles are closer together. We see lightning before hearing thunder because light travels faster than sound. To increase pitch, tighten the string. To increase loudness, increase the force. Final revision idea. Always remember these key ideas. Sound is made by vibrations. Sound leaves a medium. Pitch depends on frequency. Loudness depends on amplitude. Human hearing has limits. Ear converts vibrations into signals for the brain. Answers of all questions. Chapter 11, Sound and Hearing. 1. A tabla produces sound when it is hit. How is the sound made? Answer. When a tabla is hit, its skin starts vibrating. These vibrations create sound waves in the air. These waves travel to our ears, and we hear sound. Example. If you hit the tabla softly, the vibration is small and sound is soft. If you hit it hard, vibration is strong and sound is loud. 2. How can one make a loud sound on the tabla? Answer. You can make a loud sound by hitting the tabla harder. This increases the size of vibrations, and bigger vibrations produce louder sound. Example. Light hit barabar soft sound. Hard hit barabar loud sound. 3. How does this sound get into one's ears? Answer. Sound travels through ears waves. These waves enter the ear, make the eardrum vibrate, and then signals go to the brain. The brain understands it as sound. Think about it: flute, mosquito, leaves. 4a. How is sound made by a flute? Answer. In a flute, air is blown inside. The air column inside vibrates and produces sound. Example. Blowing softly gives a soft sound, blowing strongly gives louder sound. 4b. How is sound made by a mosquito? Answer. A mosquito produces sound by moving its wings very fast. The wings vibrate and create a buzzing sound. 4c. How is sound made by rustling leaves? Answer. When leaves move due to wind, they rub against each other and vibrate. These vibrations produce sound. 5. Can sound travel through vacuum? Answer. No, sound cannot travel through vacuum because there are no particles to carry the vibrations. Example. In space, no sound can be heard. 6. Does sound travel faster in solids, liquids or gases? Answer. Sound travels fastest in solids, slower in liquids, and slowest in gases. Example. Sound travels faster in steel than in air. Try it out questions. 7. Can sound travel through water? Answer. Yes, sound can travel through water. Example. If you put a ringing alarm in water, you can still hear it. 8. Can sound travel through solids? Answer. Yes, sound can travel through solids. Example. If you tap one side of a table and put your ear on the other side, you can hear it clearly. Pitch and frequency questions. No. Is the cry of a baby high or low pitch? Answer. The cry of a baby is high pitch because it has high frequency. Thus, what about thunder? Answer. Thunder has low pitch because it has low frequency. Animal sound questions. 11. Which animals hear highest frequencies? What is it called? Answer. Bat and beluga whale can hear highest frequencies. This is called ultrasound. 12. Which animal hears low sounds humans cannot? Answer. Elephant can hear low-pitched sounds that humans cannot hear. 13. Which animal has widest and narrowest hearing range? Answer. Widest range, beluga whale. Narrowest range, chicken. 14. What is the frequency of a dog whistle? Answer. Dog whistle has frequency between 20,000 and 45,000 Hz, which humans cannot hear. Instrument questions. 15. Why does pressing a violin string increase pitch? Answer. Pressing the string makes it shorter. Short strings vibrate faster, so pitch becomes higher. Loudspeaker questions. Sula A. If coin vibrates strongly, what kind of sound? Answer. It produces a loud sound because vibration is large. Sula B. If coin vibrates slowly or quickly? Answer. Slow vibration produces low pitch sound. Fast vibration produces high pitch sound. Wave questions. Satra A. Which wave has shortest wavelength and highest frequency? Answer. Wave D. Satra B. Which wave has highest pitch? Answer. Wave D. Satra C. Which wave has highest amplitude? Answer. Wave C. 17 B. Which wave is loudest? Answer. Wave C. Because loudness depends on amplitude. Sound vs noise. 18. Difference between pleasant sound and noise. Answer. Pleasant sound has regular waves and sounds nice. Noise has irregular waves and sounds unpleasant. Review questions. 19. Why sound cannot travel through vacuum? Answer. Because there are no particles in vacuum to carry vibrations. 20. Why sound travels faster in ground than air? Answer. In ground, solid particles are very close, so vibrations pass quickly. In air, particles are far apart, so sound is slower. 21. Why do we see lightning before hearing thunder? Answer. Light travels much faster than sound, so we see lightning first. 22. Ear diagram questions. Name parts general answer. Pinna. Ear canal. Eardrum. Hema. Anvil. Stirrup. Cochlea. Auditory nerve. B. Functions general. Pinna collects sound. Eardrum vibrates. Bones increase vibrations. Cochlea converts vibrations into signals. Nerve sends signals to brain. 23. Violin question. Which string has higher frequency? Answer. String A. B. Which has higher pitch? Answer. String A. C. Which string is thicker? Answer. String G. D. How to increase pitch? Answer. Tighten the string or make it shorter. A. How to increase loudness? Answer. Play the string harder to increase vibration. 24. Wave graph question. Mark wavelength and amplitude. Answer. Concept. Wavelength is distance between two peaks. Amplitude is height of the wave. B. Similarity and difference. Answer. Similarity, both are sound waves. Difference, one may have higher amplitude or frequency. Think tank questions. 25. Is C really silent? Answer. No, C is not silent. Sound can travel in water. Marine animals produce and hear sounds underwater. 26. How to make drums of different pitch? Answer. You can use tight skin for high pitch. Use loose skin for low pitch. Use small drum for high pitch. Use large drum for low pitch. Example. Small drum sounds sharp, big drum sounds deep. Final tip for MCQS. Focus on vibrations, frequency and pitch, amplitude and loudness. Sound cannot travel in vacuum. Ear working steps. Units, hertz and decibel.